Hi, in this video I want to talk about an example that really ties into how nearly all electrical energy generation in this country and around the world happens. So, energy can be generated by changing magnetic flux. And one of the easiest ways to make an energy generator is to have a coil of wire in a permanent magnetic field that's capable of spinning around. So if the coil has a fixed area, if it's a permanent magnet with a fixed magnetic field, then we can end up changing magnetic flux by changing the angle between the area vector, the normal to our loop, and our magnetic field. So our flux would be our fixed area times our fixed magnetic field times the cosine of the angle between the two. So if this is constantly changing with some frequency, then our EMF would be equal to minus the number of loops we have in our coil times the area of each loop times the strength of our permanent magnetic field times the derivative of cosine omega t, which is just going to give me minus omega sine omega t. So for a generator, we would see an EMF that's sinusoidal, where the maximum EMF would be the number of turns times the area of our loop times the strength of our permanent magnetic field times our generator frequency in radians per second, which would be 2 pi times the frequency f, which is 1 over the period of one oscillation. So say we build a hand crank generator where there's a square loop, each side is 5 centimeters, so 0.05 meters, which means our area is going to be 2.5 times 10 to the negative 3 meters squared. And we wind a thin wire 2,400 times around that square. And the permanent magnet that we're able to get over that region has a strength of 0.5 Tesla. And since we're cranking it by hand, we're going to be limited to how quickly we can rotate things. So let's say our frequency is about 2 hertz. So if that's the case, 2,400 loops times 2.5 times 10 to the negative 3 meters squared times 0.5 Tesla times 4 pi radians per second, 2 pi times 2 hertz, gives us a maximum EMF of 38 volts. And what we would see from the signal would be rising to 38 volts, dropping through 0 to negative 38, and changing continuously every half of a second. Now, when we talk about different types of electrical energy, what we're really talking about is what we're using to spin a generator. So with wind power, the wind blows past fan blades, the fan blades turn, spinning a generator. With coal or natural gas or even nuclear power, what is happening is that fuel is being expended to heat up water. That water is then boiled, becomes steam. High pressure, high temperature steam gets pushed through a turbine, which is a type of fan, spins a generator, we get electrical energy. Hydroelectric power, we use gravitational potential energy by leveling up water behind a dam, letting it fall down past a generator. Motion of water spins a turbine, generates electrical energy. But the only type of energy that we use commonly that doesn't really work off rotational motion creating a generator is the basis behind solar cells, which are a process that we'll talk about in some of the later chapters as we get into talking about quantum mechanics. So look for that ahead. Thanks for watching.